Hey there everyone, and welcome to the next data analysis video. In this video we'll continue doing data analysis on spreadsheets. This time though we're going to look at a much larger data set. We're going to look at all baby name data in the United States. This is publicly available information available from the Social Security Administration. So in this video I just want to show you the commands that we've used in previous videos but used on a much larger data set. So the goals for this material are twofold. I want to get more comfortable with the commands from previous videos, things like group by or sort, things like this. But I want to show you how this works in a much larger data set on a much larger scale. And then secondly, I want to show you how to make basic plots. So how can you do some basic visualizations with this data? So that's what this video and subsequent ones about the SSA data are about. So given baby name data, there's all sorts of questions you could ask. It just kind of depends on you and what you're interested in. So here's a question: what was the most popular male or female baby name in 2002, whatever year? How could you plot the number of Michaels being born over time? Things like this. Okay, so before we do any coding, let me just show you where to get the data itself from. So go to a web browser and go to ssa.gov/data. This is the Social Security Administration's website. If you scroll down to the place that says Data Assets, notice it says 1 to 10 of 2019. So it has more than 2,000 data sets you can play with if you want to. So go to this little search box here and go baby state, like that. Baby state should just give you one entry, this one here. Notice it says downloads and zip. You should click on that, and then all of this data will download for you. So this is the data: name, year of birth, gender, state, and number from every state and DC starting in 1910, and it goes through 2018. So it doesn't have 2019 yet. I assume they'll update that later this year, but through 2019. This is a ton of data, so it's going to take a minute for it to download. So for me, or let's see, it's only like 2/3 of the way downloaded. Okay, it's something like 120 megabytes worth of data. So this is much more data than we were dealing with in previous videos. Like that demographics spreadsheet is just nothing compared to the amount of data here. Now when it downloads for you, I'm not sure how it will behave, but for me, it automatically unzipped into a single folder like this called Names by State. So if it didn't do that for you, you're going to have to unzip it yourself. But you need a folder like this called Names by State. And once you have it downloaded, depending on where it is on your computer, you need to drag it and put it on your desktop. As always, I'm assuming things are on your desktop. So take that folder and drag it to your desktop. That is the data we're going to be playing with. So let me just show you. I mean, we've looked at this before in previous videos, but let me remind you what this data looks like. So first of all, there are 51 text files in here, I believe, for the 50 states, plus DC has its own file. When you open it, it looks a lot like a spreadsheet, and it's going to behave like a spreadsheet. There are 5 columns, although they are unnamed. So in the code, we're going to have to name these files so Python knows what sort of the categories are. But there's a state column, so Alaska, a gender column, a year column, a name column, and then a count. So there are 14 Marys born in 1910, assigned the gender of female in Alaska. That's the data that we've just gotten from the Social Security Administration's website. That's what it looks like. Okay, so once you have that data, the next thing you want to do is go to Moodle. I'm on the Moodle page here. Go to the sample code and data files section and download this text file here, SSA name code. So what I've done for you is I've written a bunch of code that will analyze this data for us using our various commands. So I've already preloaded all of this code into my my JupyterLab notebook so I don't have to waste time typing and so I don't make a bunch of mistakes typing. But let me just point out how this, let me make it bigger here, what this file looks like. So this code is broken down by panel or by pane or by cell, whichever those words you like. So all of this you should copy and then paste into the first cell of a brand new Jupyter notebook. So open up a new Jupyter notebook and put that in there. So here in JupyterLab, If you want a new notebook, you can just hit this plus, or you can do File, New. So create just an empty notebook. I already have all this code preloaded myself. I created an empty notebook and put things in there. And then all of this here is pane 1, and then all of this is cell 2 or pane 2. All of this is pane 3, and so on. So as we move through this, you can just keep grabbing, copying, and pasting, and running as we go. So again, I already have all this preloaded myself, just to save myself the time of typing and things like this, and copying and pasting. But as I move through my own notebook, just copy and paste with me. Bring the next panel in there so you can run it with me. Okay, so here's my notebook. Again, I have these cells already preloaded, but not run yet. I haven't run any code yet. Once you run a cell, there's a little number that shows up right there. So I haven't actually run anything. So I'm going to run this first cell. Notice when there's a star there, that means it's running and hasn't finished running. So that took a second to run this, okay? So this first cell is importing all the libraries we will need. The important ones are pandas and matplotlib. Pandas, we need to read in those files as data frames. So pandas is doing the heavy lifting of eating the data. Matplotlib, we will need for plotting. The other libraries don't worry about. They're going to be needed for just small technical little tasks as we move through. Okay, so compile this first cell just to bring those libraries in. Now this next cell, pane 2, this is what's going to actually read in the data for us. We're going to actually bring those files from our desktop into this program as a data frame. Okay, so the first thing we're going to do is just, we have to access the files themselves. So this little command here, again, a lot of this you don't need to worry about, okay? But I don't want it to be a complete black box. Some of this is new. Like this sort of command here is new, but don't really worry about it. You can just grab it from me. But this line is basically saying, hey, I got a bunch of files out there, and they live here on my desktop in a folder called names by state. Then this little filter command tells the program that, hey, I want you to go through and find only the text files. So grab the text files for me, and those are my file names. So the file names are things like ak.txt for the Alaska file, ar.txt for the Arkansas file, and so on. Okay, so the next line should look familiar. Now we have something sort of more familiar for us. pd.readcsv. The first thing I do is I create a data frame called data, and I read in the Alaska file, the Alaska data, okay? Now notice, by the way, the Alaska data is a .txt file. It's not a .csv file, but it turns out this read CSV command will also work with text files, which is nice. So those text files that we've downloaded are behaving like a .csv. The only issue with those text files was that, again, the columns actually weren't named. You're going to have to teach Python what the categories are. So this next line does that. So say the columns are these: state, sex, year, name, number of people with that name. So at this point in the code, we have something called data. It's a pandas data frame, and it just is the Alaska data. The thing is, though, we don't just want the Alaska data. We want all the data across all 50 states plus DC. So this for loop here goes through one at a time through the different file names, reads them in, reads in the different files, categorizes them, right? Gives names to the columns so Python knows what categories they are. And then this command right here is pretty nice. Concat, that is short for concatenate. This is like an append command. The append command for lists. It just takes this this other CSV file or .txt file that you've just read in and throws it at the end. So we've already read in the Alaska file. Next we'll read in the, what would come next? The Alabama file, AL, we throw it to the end. Then read in the Arkansas data, throw it to the end, and so on. And we just do that through all of the file names until we've grabbed all the data. Now, if you notice, there was some duplication and redundancies in what we did. So this last command just says, hey, drop duplicates from the data. Okay, so this pane here, you can treat it mostly as a black box, but I don't want you to think it's just a complete black box. So I wanted to explain a little bit. But by the time this is done running, this data frame will be all that data. All 120 megabytes of data. So I'm going to run this now. And notice here, the star, As long as there is a star there, this cell is still running. So this cell is actually going to take a little while to run because there's so much data to read in, and it's got to be categorized as you're reading it in, right? So even as powerful as Python is, it cannot instantaneously eat all of that data. There's just so much of it, millions upon millions of baby names are in that data that need to be read in. So while this is running, let me just point out that this right here, what we're doing right now, is why we are switching to JupyterLab notebooks and not using Spider anymore. With JupyterLab notebooks, when you run a cell, like we've already run this cell up here, right? That is now locked in for any future cell. Any future cell you run knows that you've imported these libraries here. So that means that here, after this cell is done running, any subsequent cell will know what this data is. This data has been eaten in, and now that action has been locked in. So what does that mean? That means that you can now just like do all sorts of stuff with this data later without having to eat this data in again. And this is in stark contrast to Spider. With Spider, when you clicked play on Spider, it ran all the code, So you can do this thing here, you can do it in Spider, but then every single time you wanted some code to run somewhere, it would have to re-eat that data. And it takes a while, right? The star is still there. Oh, it just quit, right? So that was like 45 seconds or something, right? Which is not a super long time, but it's still kind of obnoxious to have to sit here and wait and fill the time with me talking, So anyway, this is the advantage of the notebooks. You can run this cell, eat all that data in, and now in subsequent cells, this data thing right here, it exists within this program, and you don't have to eat that data in again. So just to show you what data is, I'm going to create a new cell. I'm going to do escape B. That creates a new cell below. I'm just going to ask Python to show me what it thinks data is. And check this out. It has column names, right? State, sex, year, name, number. The column names I gave it. Here's the beginning of the Alaska data. And if I scroll all the way down, Wyoming data. Wyoming is the last state alphabetically. 2008, there were 5 Xanders born in Wyoming. So check this out. More than 6 million rows of data, right? Isn't that nuts? So all of that data has been eaten in, and it's now a data frame. It's now a table within your program itself called data. And now in subsequent cells, we do not have to read this data in again. So let me just show you a few of the subsequent cells just to give you an idea of what we can do now. So this pane 3 is just pointing out that, hey, once you have data read in, you can now do data slicing like we've done before. So you can slice by state. So you can tell it like, hey, Python, go within the data frame and just pluck off where the state is Missouri. So if you run this, and again, I can do escape B to create a new panel down here. Just ask it to show me what it thinks this is. So notice, 1910, Mary, whatever, but notice the state is Missouri, right? And if you scroll all the way down, state is Missouri all the way, right? So this is just, oh, look at that. 5 Zebulons, born in 2008 in Missouri. Never heard that name before. Anyway, so I've sliced off the Missouri data. Okay. Oh yeah, so here, notice there's this gender column, right? I have female Marys, female Helens, and so on. Now, what if you didn't care about gender? Like, what if, I don't know, Virginia, right? There were 128 female Virginias in 1910. What if there were some male Virginias, and you just wanted the name Virginia recorded, but didn't care about male or female? You just wanted to know the total number of Virginias. Or who knows, maybe there were some male Ruths or something, right, born in that year. How could you do that? Well, if you want to just sort of ignore gender data, then you can use, oops, I don't want to uncomment that. That's my comment explaining. Uncomment this, okay? What can I do? I can group by, there's that group by command, right? I can go within the Missouri data. So this group by command here, syntax, we've seen before. Group by, first of all, I want to group by year, don't I? Right? I want to keep things stratified by year. So I want to group within 1910, group within 1911, group within 1912, and so on. But then what else do I want to do? I want to make sure that I subsequently, see, this is nice. You can give it a hierarchy, right? Group by year. Then once you've done that, group by name. So within 1910, group all the Marys together, both male and female, if there were any males, right? Group all the Helens together, both male and female. And then you can just add the numbers. So if there were 611 female Marys, maybe there's 10 male Marys, right? It would just add the 10 to the 611 and give you a genderless data frame. So here's how you can move from gender data to non-gender data if you want. So let me run this cell. Let me comment out. Leave that. Okay, so now if I run data mo like this, check it out. The gender column is gone, right? And it's sort of alphabetized things. I don't know if you want it or not, but there you go. There were 6 Aarons in 1910, where we don't know how many were female or male. We just know there were 6 of them, There were 22 Adeles in 1910. Presumably those are all females. Who knows, right? But maybe like 5 of them were males and 17 females, whatever. So as you move through this material, and as you try to answer questions about baby names, you can keep gender information or not. It's just sort of up to you. But if you're going to forget about gender information, this is the kind of thing you have to do. Group by year, and then make sure the names subsequently are grouped together, and add up the numbers. Okay, so again, all this is doing is just saying, hey, within 1910, so we're grouping by year. The years have been stratified. For every single name, like Aaron, like that, right? Find the number of them and add them up. So since we've grouped that way, it'll take male Aarons plus female Aarons, spelled like this, and add them up. Okay, that's enough for now. So in the next video, we'll just keep moving through the panes and talking about what each of them is doing.